All right, so let's go ahead and get started. So the first one is factoring when a is not equal to 1. So I told the students I would work through this a couple different ways, and I know there's kind of more of a very, what is it? A popular kind of post is like a new way of like solving quadratics that I remember looking at, and I didn't kind of cover. I didn't have time to kind of cover it, be going through this, but I want to kind of discuss like two different ways to think about this problem. And because one of the things that I think comes up a lot with in Algebra 2 is a lot of students will learn like how to do it the one way. And then when we get to like pre-calculus or higher above, students like they can only refer to like that one short way, and they don't really, it takes them too long to understand things. So what I'm going to do is I'm going to explain it kind of the way that I was taught, but that's not really the reason why I'm teaching it, just because I was taught it that way. It's really just for the simplicity of really understanding what's going on. And then I'll go through a longer form version, which is very helpful in case you get stuck trying to factor a quadratic, because a lot of times not every quadratic is going to be factorable. So you want to make sure you have a technique and a method that you can follow to be able to see if it's going to be factorable across real rational numbers. So first thing, when we want to factor a quadratic, we know that we can factor it as a product of two binomials. So what I'm going to do is I'm just going to break this down into two binomials here. So remember, when you're factoring or when you're multiplying two binomials, the first two terms are going to give you this first term, 2x squared. So assuming that everything is going to be in integers here, we can say that's going to be 2x and 2x. Now the last two numbers have to multiply, or the last two numbers that I multiply in these two binomials is going to give me a -3. So again, I really only have two options. I have -3 and +1, or +1 and -3. Now again, just with a little bit of thinking ahead, I can see that if I multiply 2x times 3, that's going to give me a 6x, right? And then if I subtract 1, that's going to give me a 5x. And that's exactly what I'm going to need. So again, like this method, I remember my teacher, like it would, it'd always be like, how are you understand? Like, how are you seeing these so quickly? And again, it really comes down to a lot of practice. Like even in my class for pre-calculus, I give my students a ton of these types of problems. Very simple, only when 2x and 3x are the coefficients. But again, it's just that repetition and that practice, you start to see these patterns a lot quicker and easier. And again, if you were to always multiply this out, oh, crap. I totally forgot. Hold on a second. I was going so quick that I forgot to put in my Ethernet cord. So therefore, I was going off of my Wi-Fi, which is not really ideal. So I do apologize for that if you guys were getting some drops on my live on the stream. So let's go ahead and try to connect it from there. Let me see if this ends up being a little bit better. So hold on, there might be a little issue, but we'll kind of see how this goes. I think we're good. All right, so I'm just going to go ahead and continue on, and we'll just kind of go from there. All right, so I don't even remember what I was talking about. The inner and the outer, when you're like multiplying these, needs to be positive. That's why you want 2x times +3 to give you a 6x, and then this to give you a -1. That's going to add to give you a +5x. If this was a -5x, then you'd want that to be a -3 and that to be a +1. In the same regard, in the same case, like what if we only wanted a difference of 1? Well, then the 1 and the 3 would need to be switched, right? Because if you multiply 2 times 1, that'd give you like a +2x, and this would give you a -3x if that was a -3. So you can see how that would give you a difference of 1. But again, those are your really only two options that you have. Now, let's say everything that I just said to you was very, very confusing and you're not at that stage at all. So one of the other techniques we can use, which I haven't even done in a very, very long time, is using what we call like the AC method. So what you can do in this case is just multiply 2 times -3 to give you a -6. And again, you can use kind of sometimes these little diagrams to kind of understand what we're looking for. And then in this case, we can take the middle term, which is going to be 5. Now what we're doing is looking for what two numbers multiply What two numbers multiply to give you a -6, but then add to give you a +5? Well, in this case, you can see a +6 and a -1, right? 6 times -1 is -6. 6 plus -1 is going to be 5. So now what I'm going to do is I'm just going to break up a 5x into a 2x squared plus 6x minus x minus 3. Now, again, a lot of students have confusion with this, and sometimes also you could do the box method, which is another way of looking at that, like thinking about area, which works as well. But again, I'm not going to, well, I guess you could. 2x squared plus 6x minus x minus 3. So you can kind of do the same thing, and then what you're doing is now by factoring out, you're kind of looking for these side lengths here. But again, I don't want to get to too many different techniques here. But basically by reorganizing everything this way, now what you can do is kind of factor by grouping and factor out their common terms, which in this case, you can see that these share a 2x, and that's going to leave you with an x plus 3. And here they share a -1, and that's going to leave you with an x plus 3. And then you can factor out the x plus 3, and you can see you're going to get this exact same answer, 2x minus 1. Now, this works great because it's going to give you the same answer, and you can just follow the steps. But as far as understanding why you want to do this to this, why the grouping, I think just creates more confusion, and students just don't really remember it or really understand it. So that's why I kind of lean to this method as far as understanding the patterns and understanding the technique as far as what we're looking for, right? When we're looking for factoring, we're looking for this to be broken down into a product of two factors. This is great to follow step by step to understand it, but I also feel like a lot of students don't really make that connection with there. Now, again, I've spent way too much time on one